Hi. We are given a bunch of scores and are to convert them into grades represented as letters. Here are some scores. They are arranged in a table, a 2-row, 3-column table, and the shape doesn't matter. We need to be able to handle any array, but as we'll see, that won't be a problem. Let's start off with a little lambda, or a defen, and we refer to the argument with the letter omega, the rightmost letter of the Greek alphabet. Now we use the interval index function. It gives us the indices of the elements on the right in a lookup array on the left. But it's not just finding those elements there. It is the intervals. So the array on the left has to be sorted, and we figure out which interval would the right side elements fall into on the left. Let me illustrate this. So we write our cutoffs from the table. And now we go and look up 71. It's not in the list of cutoffs. Instead, it would fall in this interval. And the intervals are inclusive on the left and exclusive on the right. The last cutoff goes for infinity after that. And this is interval number 1, which falls after the first cutoff. We can see that by 59, which falls in that first interval, which ends before 65, begins at 0. If there were any elements that would go before 0, that is negative number, then we would get a interval number 0, but by default that's not a proper index and we don't want that. So therefore we begin with 0, which is the cutoff for the first element. APL supports multi-indexing. That is, when we index into an array, or a string in this case, then we can index using multiple indices. The result is always has the same shape as the indexer. So here we get an array of 2 rows and 3 columns of indices, and each one of those indices will then be applied in turn to the lookup array. And this effectively translates the indices to this alphabet. And here we have it. These are the letter grades. Thank you for watching.